All right, now that we've talked about relations and functions and one-to-one functions, we're in a place to define inverse functions. So the definition is here up above. So if f is a one-to-one function, then its inverse function, which we write as f with this little -1 up here, is read as f inverse, is defined by the rule that f inverse of a number b will equal to a if f of a is equal to b. So put another way, what the inverse function is doing is it's reversing the input and output values for the function f. So you see that the original input here is a, and that becomes now the output for the inverse function here. And then the original output here is b for f. That becomes now the input for the inverse function. And to further illustrate, let's say I have this function here where f takes 1 to 5, 2 to 4, and 3 to 6. So for its inverse, what it's going to do is just reverse the arrows, essentially. We're now thinking about the outputs as becoming the inputs, and the inputs here is becoming the outputs. And so now what the inverse is going to do is it's going to take 4 back to 2. And it's going to take 5 back to 1. And it's going to take 6 back to 3. This is what the inverse would do. Okay? Now question 3 on the worksheet says if f is 1 to 1 and f of 3 is 7, okay, then f inverse of 7, what would that equal? Well, it's just, again, it's reversing inputs and outputs. So f inverse of 7 would be 3. Part B says if g is 1 to 1 and -2, -5 is on the graph of the function g, then what would be the corresponding point on the graph of the inverse? Well, the thing to highlight here is that if the point -2, -5 is on the graph of the function g, that's saying that g of -2 is equal to -5. And so for the inverse, we just reverse input and output. So I'm going to have g inverse of -5 is equal to -2. And this statement tells me that the point -5, -2 is on the graph of g inverse. Okay, great. Now the last thing I want to say here in this video is, well, what can happen if your function is not 1 to 1? Well, to illustrate, let's go ahead and look at a non-one-to-one function. Let's say 1 gets sent to 4, 2 gets sent to 4, and 3 gets sent to 6. So this is not 1 to 1 because the output of 4 is coming from the inputs of 1 and 2, so it's not 1 to 1. Okay, so now what's going to happen if I just try to reverse the roles of input and output? Well, let's see. If I'm going to reverse the roles here, then 4 would want to go back to 1 and to 2. So we would have that. Well, 5 here, right, doesn't come from anything, so it's not going to be mapped to anything here. And then for 6, that would go back to 3. See, here's the deal. This relation is not a function now anymore. Okay, so here, this is not a function. So if we want this reversal of input and output values to result in a relation that's a function, well then if your original function's not 1 to 1, then you're going to have issues in trying to do that, right? Because that relation you wind up getting will not be a function. So this is why we insist that the function f here in the definition of inverse function has to be 1 to 1. All right, we'll stop there. Thanks.